Hello everyone, welcome to my channel Coding Together. My name is Vikas Odha. Today we will see another Leetcode problem, that is clone graph. So we are given with a reference of a node in a connected undirected graph, and we have to return the deep copy of the graph. So if you don't know about the connected and deep copy, you can go in this link. And so let me tell you what deep copy is. So for example, we are given with a graph 1 2 3 4. So we want to create a graph in another space with all new memories of the nodes completely in another space. So if you see here, the color of the node 1 is changed to blue. So we have created a corresponding node for 1. We have created a corresponding node for 2. We have created corresponding 4, and so on for 3, and we have joined these two nodes, and all the edges are same, but this is in the new space. Means this is not the same node. We have created a copy of the each node and each edges. Now the test case format is that to simplify, the indexes of the node is starting from 1, so, and the value is also 1. LU is also starting from 1. So for this node the value is 1 and index is also 1. For this node value is 2 and index is also 2. So it will simplify the solution. And adjacency list, we have given a list of list. So this is a list that is 2 4 that represents the neighbors of the node 1. So 1 has neighbors 2 and 4. So this is in the list 2 comma 4 that represents the adjacency list. So there are two things that we have to keep in mind, that we don't have to return the same graph, like here and here it represents the same graph. And if we are doing the deep copy but the order is changed, that's also not acceptable. If, like you see, there is 2 and here is 3, so the order is changed, so it's not acceptable. So let's see how we can approach this problem. So we can do this problem using DFS and BFS approach. So today we'll see BFS approach for this. So this is already, I have taken the adjacency list here, and this is the original graph. Now what BFS says, that we need a queue. In BFS we use queue, and we will make one more new data structure, that is map, which will store the key and the value. The key will be the original nodes and the value will be the new nodes. So let's start. So first of all, we'll add the starting node, that is 1, inside the map, and we'll create a corresponding node in another space in the new graph ng, the new node 1, and we will add it as a value. Now you know that when we added the original root node, or you can say the starting node, the adjacency list will come as is because it's associated with it. So if you know that 1 is associated with 2 comma 4, means they are the neighbors, so we'll keep it as it is. And for now, in the new graph, the value 1 will be empty for now, and we'll add it in the queue. So let's poll the queue. So how BFS works, we'll poll the value from the queue. So we are on the current node as 1, and they have their child nodes as 2 and comma, they have child nodes as 2 comma 4, or the neighbors. So we'll first check whether 2 is present in the map or not. No, 2 is not present in the map, so we'll add the corresponding original 2 node inside the map with their adjacency list, its adjacency list, and then we will create one node 2 in the new graph, and we will also add it as a value corresponding to this key. Now we will add 2 in the queue. Okay, so we have added in the queue. Now we have to check for the connection. Like in the original graph, 1 was connected with 2, so we have to connect 1 with 2 in the new graph as well. So what we will do is, we will, as we are iterating the original graph, so we are going to the node in the original graph. but we have to add a connection in the new graph. So what we will do is we will find the corresponding value from this key for this node in the new graph with the help of this map. So if we will do map dot get 1, it will give you the corresponding value for this key for this node in the original graph, and then we can easily say that please add the adjacent node, that is 2 to 1. So we can say that 1 is associated with 2. Now what we will do, we will go for the another child, that is 2, for the current element 1. Again we will do the same operation. We will check in the map, 4 is not there, we'll add 4 with its neighboring list, that is 1 comma 3, and we'll create one more node in the new graph with an empty adjacency list. Now we will check that 1 is connected to 4 in the original graph, then we'll connect 1 and 4 in the new graph as well. So we'll add 4 in the adjacency list of 1. Now we'll also add in the queue. So now the 1 is over, all the childs are covered, so we will extract our next element, that is 2, and we will check that the adjacency list of 2 is 1 comma 3. So we will check for first 1 whether 1 is present in the map or not. Yes, map is present in the map. 1 is present in the map, but we have to join 2 and 1 because it's undirected. So you cannot see the arrow, but it would like that it is already joined, it's undirected, so we have to make it two-way. So how we have to, what it means is 2 has adjacency list of 1 in the original graph, right? So we have to also mark as the adjacency list of 1 in the 2. So what we have to do is, what we will do is we will do map dot get again 2, that will fetch the value from the map corresponding to this key. So here it's 2, it's associated with 1, we'll get the key 2 from the new graph, and we will say that 2 in the adjacency list of 2, please add 1. So we'll add in the neighbors of 2, or in the adjacency list of 2, we'll add 1. Again we'll see 3. So 3, so also if it's in map, as we saw that 1 was already in the map, we will not add in the queue. We will only add in the queue when there is no entry, when the node is not created in the new graph. That's the point. Now we will see the next child 3. So now here if you see, it's not present in the map, so we'll add in the map with the adjacency list as 2 comma 4, and we'll create one more node in the new graph. So, and then we will add in the queue. Now we will see that 3, there is a connection between 2 and 3, so corresponding values from the new graph will add a connection, and we'll add that 3 is the adjacency list in the new node in the new graph as well. Now we will extract 4. 4 will give you the adjacency list as 1 comma 3. So 1 is already added, so we'll not add it, in the queue. We'll check whether 1 has any relationship, has it already been connected or not. Yes, it's not connected. 4 to 1 was added in the list, in the adjacency list, like 1 is in the neighbor of 4, but in the new graph 1 is not in the 4 neighbor of graph. So what we will do, we will again fetch the corresponding values for 4 and 1 from the original graph, and we will add the adjacency list here. So we will add, we'll say that 1 will be the in the adjacency list or the neighbor of 4. Again we will check 3 is already present in the map. Now no need to add new node, just we have to connect the new nodes, that's it. So we will check, we'll fetch the corresponding new node with the help of this current element from the map, because this is what we are iterating on the original graph, not on the new graph. So we want always the new node from where we want to add the edge. So here the map will help us to find out the values or the new graph nodes. So if we do map.get4, it will give you the new graph node 4. Similarly, you can get from 3, and you can say and then you have the new node 4 and 3, and just mark the neighbor of 4 as 3. Now we will extract 3 from the queue. So 3 has 2 and 4 as their adjacency list. So we'll check 2 is already in the map. We'll not add it. We'll just add the adjacency list in the new graph, new nodes, as it's 3, 2. So we'll say just add in the new node in the new graph, the 2 as a adjacency list. Again, we will check for 3 and 4. So we will get the corresponding new node from the new graph as 3, and for 4 also we check that it's already present, so no need to add it, and we will correspondingly fetch the new nodes with the help of map from the new graph, and then we will add it into the adjacency list. So 2 is already added, and we'll add 4. So our queue is empty. We are done in this way, and we are ready with the new original graph. So let's see the code part of it. So here, if you can see, we have our first, if the node is null, so we'll return the node. So whatever the node is coming, if it is null, we'll returning the null, or if it is whatever the node is, we'll return node as it is. Now we will create our auxiliary helping map that will point to the original and the new node, that will map original nodes and the new nodes mapping that will have. Now we will start with the queue, and we will put a node inside the whatever the node that we are receiving, the original node, the starting node, will put inside the queue, and will create a new node corresponding to the original node and put it inside the map. So to start it, and then we'll perform the while loop. So we'll fetch one by one from the queue. Just the BFS, we use the queues, and we'll pull each element from the front one by one. So first of all, we'll get our original node. So suppose we got 1, and for the original node, we'll iterate over all the neighbors of the original node, and if that is present in the map, if it's not present in the map, then we'll create a new child node, and we'll assign the value from the child that we got from that is the child of the original node into the new child value, and we will add that child in the queue as well, and we will put that in the mappings as well. So now if it is not contained in the map, that we have to do. Now after the map we have put into the map, then we have to add into the neighbors of the original node with the their neighbors. So we will first fetch. So this line, if you see, map.get, as I was talking about. So here we were always fetching map.get because we don't want to add the edges or the adjacency list in the original, we want in the new graph. So that's why we are always doing the map.get original. So that will give the new original node that we created, and for that original OG1 means the new original, we will add the neighbors, and neighbors will be also what we will fetch from the map.get child. So that's very important, because if we saw that 2 is associated with 1 in the original graph. So to fetch to join 2 and 1 in the new graph, we will fetch the corresponding value of 2 from the map, that will point to this, and then we will get the corresponding child of this corresponding value from the map for this child. So 1 is associated with 1 in the new graph, so this will give you this node, and then we will join these 2 nodes. So this is very important, that we are getting always the map.get and map.get. So simple BFS approach, and finally we will return the node, map.get node. So we stored this value key as the original, and we want to return the new graph. So we stored the value corresponding to the original first node in the map, so we'll return that as a map dot get node, the original node that we stored in the map. So yeah, so let's run this code. Yeah, the test cases are passing. So hope you like this video. So for more such videos, please share and subscribe, and we'll see you next time. Thank you.